Okay, there we are. Okay, thank you guys for being here. I was not available 2 weeks ago, and it is true that my software is taking a lot of my time. And I apologize if, of course, most of the topics are because of being short of time. I mean, I don't have really time to go out of my way. So I'm going to review vol surface again. It's an interesting topic. It's more like a wrap up because we've talked about it in several sessions, and since I started in I think August, September, and I hope it will clarify a few things. And time permitting, I'm going to show you what I'm doing with my software SOAP. Okay, feel free to unmute, and this is a small group, so if you have any questions, rather talk than chat because I don't see the chat box. Okay, as usual, there's no need for a disclaimer, but this is my usual one. Of course, this is 100% educational, although it could be seen or deemed as commercial information if I talk about soap. But I mean, really, this is not what I'm looking for. So before going into vol surface, I'm wrapping up the last session about backtesting. I think I made I put really backtesting from a statistics perspective really on trial. I had quite a number of strong arguments against it. And I kind of mellowed out at the end of the session saying, well, yes, of course, it's a good learning tool. But what I believe, because being also a mentor, I see a number of beginners or people who are slowly taking off, being stuck with rule-based strategies type of thinking, and they look at the backtester in one option view as one essential tool. And I think, and that's what I've been trying to do and to express since I started, is that it's much better to learn the dynamics of options so that you don't really rely on those tools. Of course, one of the motivation for me was and still is that I don't trust black boxes anymore. So modeling is an issue, and backtesting is a very serious issue. And as I said, and I actually also reiterated on Tuesday in the training group 1, if you want to go for backtesting and if you don't feel confident to think out of the box and start dropping rule-based trading, at least do it properly. A lot of people, I mean, I remember people complaining that option view was too slow when they pressed the next button to move to the next, whatever, half an hour or whatever time interval they use in the backtesting, 1 hour or 1 day. They think it was too slow. And I said, no, you have plenty of time because you should be looking, you should really put yourself in a position of a real trader and look at the environment. What were the news on that day? What was the VIX contango backwardation? Was it earnings season, dividend season? All those things people tend to completely ignore or at least overlook most of it. Right, so that's the end of my usual ranting again, backtesting. But really, what I'm trying to say is that knowledge is key. Knowledge is power. If you can really grow your trading into your own personal style, feeling more confident and also trusting your tools, you will be a much better trader. Okay, so as usual, this is on the same line. These sessions, although they're not exactly training course, I feel it's important that you get to understand the dynamics. So, and I remember that, well, we tend to assume that, I mean, of course, everybody's got at least some surface level understanding of Black and Scholes. And of course, it was designed at a time where implied volatility was flat across the board. And we've seen in earlier sessions that you can derive the IV from well-known algorithms. You don't actually really need to know what's in there. And I quote three of them. Newton-Raphson, which is the most common one. It's actually a root finding algorithm. It is not at all a option limited to options trading. It's if you want to find the roots of any function, any continuous function, Newton-Raphson does it well if there's only one unknown variable. Nelder-Mead is a little bit more powerful. It can actually find double roots, and that can be interesting if you are trying to put also the dividend yield as an unknown, so volatility and dividend yield. But I don't actually use it much. I rely 100% on Newton-Raphson. There's also bisection, and if you contact me, I've got all of those coded in Excel spreadsheets if you want to practice a little. So we all know that there's a skew, a vertical skew across a chain. There's actually two vertical skews on the put side and on the call side, but we know that at least for European options, through put-call parity, they should equate, they should fit together. They don't always, because market makers sometimes don't play ball correctly, and even more so before market opens. If you try and extract prices and from that derive IV before market opens, and here I'm in Mauritius, but in Europe, or at least in this European time zones, the market makers start pricing options from 8 a.m. in the UK, and you will see that the put-call parity is absolutely not respected at all. So, and I understand that if there has been a gap, maybe some crisis arising from Asia, that will of course pervade through Europe and then America later on. Even though the markets are not open, market makers will definitely price put much higher. So you have to be aware that if you do analysis before market opens, even though you get prices, you will be taken for a ride. And that's also a reason why, if you have to place an order, let's say GTC, outside regular trading hours, you have to be careful, especially if you go market because you have a margin call or anything. They really they are there to eat you up. So that's just a little warning that if you look, and of course here, because I'm in Europe or European time zone more or less, and I see what they're doing. While you're still in bed in America, I definitely see. Excuse me. I definitely see what they're doing. I see there's a chat. So, oh, two chats. Okay, what is it? Where's the chat box? Chat. I'm sorry, I don't see the chat box. I don't know what's going on with this. Sorry about that. I don't know where it is. I think when I share screen, it's okay. So please, if you have any question, if you have a mic, please talk. That will be much easier for me. Right. So we know that we can easily model the vertical skew through a polynomial regression. It looks more or less like a parabola, by and large, you know. And a lot of people tend to ignore the horizontal skew across time chains. And if I'm going to try and keep, yeah. And what am I raising that issue is that there was that guy I put on my slide recent webinar, but that was actually the last trading group. Why does one need vol surface at all? I didn't want to get into that at the time, but when you start modeling things, and some of you have played with the various spreadsheets I've posted or sent via email, is that if you, when you model a position using individual volatilities, and of course you derive the proper IV across the range of values you want to look at for your underlying, you can model a curve, a t+0 curve, and you can also model your Greeks. They're quite easy to calculate. But basically you have that Black-Scholes formula. You plug in an IV, you derive, you extract from prices, and then you just plug it in. And then using that, you actually can plot, and I can show you on SOAP. This is SOAP. I could put on one, but anyway. So I extract IVs from prices, and from that vertical skew here on the put side, I can actually figure out the whole t+0 and my Greeks. That is very easy to do. Now, the problem is that if you don't take into consideration the horizontal skew, you assume that this set of IVs, this dollar sample, never changes as time goes by. And that is completely wrong. Nothing can be more wrong than that. So ignoring the horizontal skew, so ignoring that third dimension, that time dimension, is almost as bad as assuming that IV is flat across the board. It's just, I mean, to me, it's very much inconsistent. It doesn't make sense at all. So that's a reason why we try and extract IV, not only from the chain we are working on. For example, on the chart, on the risk graph and matrix that I just showed you, it was a March position. What we need now is to actually grab some data for expirations, maybe from 14 days to, I think March is about 36 days. So and of course, you don't really need to go too close to zero if you don't actually need or want to trade that close to expiration. So you take a set of expirations from your expected exit date to the time, the DTE, or the time to expiration for your current position. There's no need to actually model further on, unless you assume that there could be modeling errors and you want to also average further down. So for example, if I use March as 36 DTE, you may want to use also March end of month, so to have another 12 days, so maybe like 50, just below 50 DTE. But this is not really necessary. It can be done. You can do that if you think that there could be errors at we call that border errors in modeling, but generally they're not needed. So really, when you look at your horizontal skew and you take a set of expiries all the way from your planned exit date to the chain you are working on. So there are a number of possible approaches found in black boxes, and of course there's very limited documentation. Len Yates has shared some information about what he does in OV, but it is really most of the time confidential information. I like one. It's actually a good-looking software, but I haven't got a clue how they get to the vol surface. So, and again, I was tired of black boxes, and I will show you how I do it. But also for those of you who are programmers, there are a lot of existing tools. I mean, Black and Scholes can be, of course, found anywhere for free. It's open source. But what is quite interesting is that you can be almost as well equipped as qualified quants, because you download and use QuantLib, which is a fantastic library, and also posted here some suggested reading how to implement it. So one could say that with SOAP, maybe it was out of pride, or I don't know, but I could have just plugged in the QuantLib library. I think I wouldn't have done much better than what others do, or the software do. I think I've got I've got a battery problem on my laptop. Anyway, can you hear me? Is anyone with a mic who can tell me whether I've got a sound problem?
Yeah, I can hear you.
Okay, good. Thank you, Gary. So maybe I didn't need to go that far, but I really wanted to build my own model. And I know it sounds like completely over the top, but I have explained, and I will explain even further, that it is very much a down-to-earth practitioner's approach. It is a trader's approach. I do not rely on any statistical model. I've actually introduced those, local volatility and stochastic volatility, but it's quite a complicated topic. So what we do is basically we use a deterministic local volatility, and I will explain that a bit later. So QuantLib is really the quant Bible. This is really something, and at some point, if I want to do more, or let's say I would like to model more than just vanilla options, or I want to code other models like Heston, I think I've proved to myself that I can do quite a lot with SOAP. Also, I think what I've done is not in QuantLib. It's not in one. It's not in option view. I've really used a trader's type of approach with my multiple nonlinear regression. So some of you may not want to go into the trouble I've gone into and plug in just QuantLib into any programming platform and do what I've done. If you go to the link I posted on the previous slide, you will see that it is actually pretty easy to do. I know, Gary, you're a part-time programmer, and maybe you would, if you haven't done so, you can have a look at it. It's actually quite nice. So I have interfaced QuantLib in Visual Studio. So again, this is something that we'll look into in a version 2 in the future. The good thing is that when you start playing with QuantLib, you can model bonds, portfolio analysis. You can do, I mean, it's endless. Yeah. So as I said, at this point, my own approach was that I wanted to do something I totally control and understand. Not that I wanted to go into any theory, but the local volatility model and the CEV, constant elasticity of variance or volatility. And if I can send you some documents, I can post them, or you can Google them up. There are very good lectures from E.DERMAN done in the late 90s, early 2000s, and he's done a good job, and it's fairly easy to understand. So basically, when you do a statistical, or not that very complex one, but you can model volatility through this formula. So basically, sigma ST is the volatility depending according to a strike or underlying and time. So this is really what we're trying to do. As I said, the vol surface is a function of two variables, the underlying, so basically the vertical skew, and the time, so the horizontal skew. And we get into a 3D surface. Calibration is a little bit complicated. And what DERMAN has actually shown is that CV models or actually can help the model, but they actually kind of mess up. They make the volatility surface, let's say they try and compensate the volatility surface based on mean inversion and the anticorrelation between the asset and its volatility. Generally, like we know that with SPX, in the past, the anticorrelation was more or less 0.8 or 80%. It has gone down actually in the last few years, so which shows that the last 2 to 3 years have been really different type of dynamics brewing. Something is changing on the trading scene, and of course, most quants, they're like economists. You know, they will figure out in 2 to 3 years' time that yes, it was a difficult time, or at least an unusual time, and that's also a reason why, you know, when you do backtesting, you don't know. I mean, you try and model something with dynamics that could be completely obsolete. So I will send this is basically a copy paste from one of the docs from Emmanuel DERMAN, just to say that even if you go for a more complex model, there are unknowns. There are a lot of unknowns, and if you trust a platform that is basing its research, its development on, even if it's from QuantLib or anything else, you know, you replace unknowns by other unknowns. So I think that's why I like my non-parametric approach, where I really plot the 3D surface. So my sigma ST is really based on actual points, some like you do, Gary. I know, and I know you work in a more generous environment provided by TOS. I mean, with IB, it's pretty tedious, but the whole thing is to really get a good data set of IVs for at least 2, 3, 4, or 5 chains. And from that, when you've got those points, you just try and model what is the continuous 3D function that goes almost like a least square generalization. You know, when you try and plot a line across data points, it's a linear regression. Everybody's done that at school or university. So it's just a slightly more complicated because it's nonlinear. So you first have to linearize your variables, and it's more than a 2D data set. So that's why it's a little bit more complicated, but the principle is exactly the same. Another thing which I've mentioned in previous sessions is that if you want to, I would say, make your vol surface, your function, more portable, more adaptable to various environments, you should not use the strikes as your x-axis. The reason is that, of course, price of the money changes, and you know, if you calculate IV 20 points lower, 20 points higher, I mean, this is impossible to actually reuse the vol surface. So you will have a snapshot of what the vol surface looks like now, but it's going to be very difficult to reuse. But on the other hand, if you swap the x-axis with moneyness, and moneyness can be either just a straight moneyness logarithm of log of S over X, so the strike over the at the money price, you will get a more symmetrical view, and it's going to be independent on the you know, the price themselves. So they're going to be a lot easier to use. The good thing also is that if you don't use a log, you will introduce some asymmetry. I mean, you all know that when an asset goes from 100 to 110, it's plus 10%. If you now reduce it by 10%, you get to 99, not 100. So by using a log, it's a symmetrical variation, so it's a lot better. And generalized moneyness is we also compensate by the ATM volatility, and actually it's not sigma ST, it's actually sigma ATM. There's a mistake here. And the square root of the time to expiration. So really what I've said before, and I want to really emphasize on that, is that you get real data points from prices. And this is really what a trader would do. A quant will look at all sorts of stochastic variables, statistical distribution, and all those things to figure out where the price should be. And yeah, no, I mean, this is really very much down to earth. The only maybe slightly more complicated things to comprehend is the multiple nonlinear regression. But my SOAP is not a black box, and I'm sharing the inside. Not that my software is freeware, but I've worked very, very hard on it. But if anyone wants to, I mean, I know I'm going to sell it. At least I hope it will build confidence in the software, knowing exactly what's in there. I'm not hiding anything. And anyone who wants to build his own, I will gladly share pieces of code. I don't know whether with TOS you have vol surface available in the platform. With IB, it's actually a Java applet that you basically from the TWS, the trading workstation, I don't know what it is, from IB, it actually sends you to a web page, and it's a Java thing. So this is what a vol surface looks like. And of course, it looks easier to understand when you have the strikes as an x-axis and the time to expiration in days as the y-axis. And it is true that, I mean, this is a common shape for indices and stocks. And it looks fairly easy to model, which is a good thing, because if it's easy to model with not too many aberrations, you will definitely find a 3D function that can actually fit the actual data points with very little error. So that's the good thing. And but they, maybe because moneyness is, looks and sounds artificial, they don't actually use it. But if you use moneyness here, you will have a much better looking curve, and it will make your modeling a lot more accurate as well. So strike-based, it looks nice, but it's almost like useless in terms of analysis. So in the session 7, a couple of months ago, I mentioned that I based my work on a publication from Dumas Fleming Whaley, 1998, and updated in 2002, and also showed that there's, for those who want to build their own on Excel, there's a guy called Brian Byrne who's done a good job on a series of videos. And generally, if you want to be able to capture this type of shape, you would at least need a 2D function. I mean, at the very least, you see that it is a collection of quasi-parabola type of functions. So this is what you should be using at the very least. Since that time, and I think on that slide 2-3 months ago, I said, well, that could be extended further. And that's exactly what I've done by adding more terms to this equation. So now I also use x squared t, xt squared. So, and if you do that, if you actually add more terms to your model, and it's only an extra 2, I mean, no big deal for a computer. So by using a 7-point model and not just a 5-point model, you actually capture what you often see. And actually, you can actually, you know, sometimes you see things even though they're not really visible, but there's a slight concavity. It's not a perfect parabola here. Actually, when you go OTM, and I know a number of traders go OTM, you will see that there may be some opportunity pricing of maybe it's going to be around 10, 20 delta. And I know a number of traders and expert traders have that intuition that there's something to be done in a 10, 20 delta, placing spreads but if you can actually figure out that on top of it, there is some concavity, that means that there may be a more interesting price for your short here than your long further down. So it will also help you figure out maybe if there's a pricing opportunity. Because let's not forget that when the volatility jumps up, like is done on a number of occasions, it's generally the ATM volatility, and how it actually pervades through the chain is difficult to model unless you have some good model about your vol surface. And that's it. Yeah, I think that's it for my talk. So now I'm going to show you SOAP, if you don't mind. So this is SOAP. I have actually, so this is a March expiration. I will have a full-on round table to show all the features. But what I do here is, if I go to the main menu, basically you collect the data that you use for your trading, and you also click on vol surface settings. And vol surface settings, with vol surface settings, you actually select the expiries you think are useful to build your own. And I know, Gary, you can post that it's easy to do with TOS, but with IB, you have a lot of limitations in terms of concurrent data captures. You can't really go over 100, or for some reason I have managed to overcome that limitation, but I know if I push it, I'm going to be my throughput will be throttled, and I will get no data at all. So basically, this what I call streaming data is the data I use, and it's streamed on a live basis, continuous basis. So this data is updated all the time. My Greeks are calculated. IV, sometimes I use just the IV from the broker, but I can also calculate it myself. If I want to not rely on the broker's IV and calculate my own, it's going to calculate it. And as you can see, there's hardly any difference. It's about the same. So, which is a good thing. You want to also test your model against a data that you assume you can rely on. And I've heard that IB's IV is one of the most reliable ones. So that's also a good thing for my modeling. So my modeling is similar. So this is the live data, but on what I showed just before on the main, what I do is I actually select a number of expiries, and those expiries, I'm going to call data on an off basis, and it's computed on a separate thread that actually collects data every 5 minutes. So the good thing is that compared to other platforms, where and it is the same for one or option view, when you log in, it downloads a data model for your vol surface, and you have it for the day. Of course, I suppose if you log off and on again, maybe it's going to be recalculated again. That's a black box, you don't know. Here, I know every 5 minutes, I collect a new set of data. And because I've selected for my March trading, I've selected that I wanted the puts and the calls from end of February, March the 6th, and March 13th. So basically every Friday, because there's better volumes on Fridays. I know SPX has got 3 expirations per week, and I could maybe go overboard. But you know, I'd rather select the Friday weekly expirations. They are definitely more liquid. So at the background of this one, if I click on this button, I get to the snapshot button. I call it a snapshot button because my vol surface data is made of snapshots. So as soon as I get this data is actually retrieved, my requests are cancelled, and I do that on a regular basis. So here I've got IV, and of course here this is 100% calculated IV. I don't use IBIV. I calculate it. So basically, as you can see, I've got my live data plus 3 different expiries. So I've got four vertical skews, so to say. And with these 4 vertical skews, of course, if I have more, it's going to be more, the granularity will be finer, and I will probably get a better looking vol surface. But with 3 or 4, you generally get a good shot at it. So from there, I go to implied volatility, and I can calculate the vol surface. If you really only care about the put side, you can do a vol surface on the put side. If you want to stitch the put and the calls together and get a vol surface for both, you basically increase your number of data points. It's going to make a better looking vol surface. But if you remember what I said earlier, if you want to prepare your trading day and you rely on data that is sent through before market opens by market makers who kind of play the fool with pricing, it will affect your vol surface. So you can do some analysis before market opens, but there's nothing more reliable than actual market data during trading hours. So this is what I do, and I've calculated it, but I can actually recalculate it. I hope it's not going to bump out. Let me recalculate it with the latest data. Calculated, then calculated. Calculate and save. Okay. So now I can go here. And there it is. So, okay, I'm not an expert in programming graphics. So I will try and improve them. But this is the vol surface, puts and calls combined for SPX from now to, let's see if I've got the legend. No. Oh, yeah. Okay, got calls here. Anyway. So this is the vol surface. And of course, if we look at the VIX Central, we see that we have a flattish, very mild contango. And if you remember what I said earlier, if you ignore your horizontal skew, you would assume that your vertical skew or your data points do not evolve over time. And actually, when you have a totally flat vol term structure, I can tell you that your vol surface mode should be very, very close to your individual volatilities. So, and these are little tricks to actually test the models in black boxes. If you have a very, very flat term structure and you see that your modeling is very different using individual volatilities and vol surface mode, there must be something wrong in vol surface mode. I mean, the individual volatility, anybody can do it. I mean, that's very simple. But I can tell you, if at this point you should have very little difference between, because it's okay. There's a mild contango. February is, to me, that's an outlier in any case. because if you look at my vol surface, I selected data only from the 20th of Feb, and it's a March trade. So basically, if I look from March to here, the slope is not that big. So if I go to my SOAP, here I'm not using vol surface, and I've got a delta 0.26. Let's see what it does if I activate vol surface. It's going to recalculate 0.8. So as you can see, and of course I know what's in there, so it confirms what I calculated. But this is something, I mean, for anyone who's got that intellectual or technical curiosity, that's something that you should do. You can actually try and get a little bit more information that is provided to you if the market conditions are right, of course. But this is a little trick. Flat term structure, your vol surface mode should be very close to individual volatilities. Okay, I've talked for 45 minutes, so I don't know whether I can get the chat box. Yeah, I'm quite useless with that thing. Maybe I'm going to stop sharing and then I will see it. How do I stop sharing? That's a good thing. Post share. Okay. Oh, okay. Now I see it. Okay. What about E-minis and ES options? Yes, my SOAP also works with ES options. Yeah. It works with individual stocks. I actually haven't tried recently, so let's cancel this data. And I'm going to call